And thank you so much for being willing to do this. I'm so glad to have you here. Could you please introduce yourself? Tell us a little bit about what you do.
Yeah, my name is Casey Dreier. I'm the Chief Advocate and Senior Space Policy Advisor at the Planetary Society, which is a nonprofit organization run by Bill Nye the Science Guy that really works to promote space exploration, get people excited about space, and get people to actively participate in making more space exploration happen.
That's awesome. How did you get into that field? Like, you have a background in physics, I know, but what led you to actually I don't want to, when I was trying to tell people about who you were, people that I was excited about what's going on here, I'm like, well, they don't really lobby. They raise awareness for what's going on with this. How did you end up with a science background to get toward that?
Yeah, so, well, first let's talk about kind of what lobbying is and isn't, and then kind of the role of educating members of Congress and our political system, because that's really important to me about how civics works, how your government works.
Mm-hmm.
And so members of Congress, they represent, their job is, the ideal case is to represent their constituency, right? And they're all scattered about the country in different geographical locations. So every member of Congress in the House and every senator in the state House is meant to represent their geographic area, state or representational district. And so it's important that they hear from the people who they represent about what's important to them. And then they also, in a democracy, get to say, what can we do to service our constituents in our own district? How can we help them? And so if you have a NASA center in your district, you tend to be, as a member of Congress, really interested in what NASA does, because what NASA does can drive the economic stability of your location, can help invest in education and, bringing people to move to where you live and improving the quality of life for people. And so it's kind of your job as a constituent to constantly be telling your representative, right? It's in the name, what you care about. And so at places like the Planetary Society, we're a nonprofit organization. We don't make money, from what NASA does or doesn't do. So in that sense, we're not necessarily lobbying for ourselves. There are companies out there who say they want to lobby Congress so they can get better contracts and that they can make more money. The Planetary Society doesn't get any benefit from that. We just get to enjoy the outcome of space exploration. But there's also an aspect of members of Congress have to think about lots of different things, right? There's hundreds of different issues to deal with, lots of different constituent interests. And so they need to look towards how do we learn and get good information so we can make good decisions about things in space exploration. And so with the Planetary Society, what we do is we reach out and kind of educate members of Congress, we educate their staff, and we say, this is how the process works, this is what's important in science, this is what's important in space. And it's not necessarily lobbying, because we're not actually going for a specific piece of legislation necessarily or a specific outcome. We just want people to be smarter. And so working with the Planetary Society or just being a citizen and engaging a member of Congress, you're helping them have a better understanding of the issues, and then they can make better decisions on your behalf, at least in the ideal case. So that's kind of the big picture of what we try to do. And then we also, as the organization, we do a lot of other things. We do a lot of education, we do a lot of outreach, and then we also build space projects ourselves. We just launched a CubeSat into space on a Falcon Heavy rocket a couple years ago that unfurled a big solar sail and is right now sailing around the Earth using the power of the sun. So we try to do a lot of different things. So how does someone end up in this position with a background in physics? And everyone kind of has, it's a little weird. And I'd say maybe the first and most important thing is that physics, so my undergraduate degree is in physics. And I really was into science as a kid, really into chemistry and physics, ultimately went with physics because I was actually a chemistry major, but I was doing all of my independent research in physics and in astronomy. And one day, like, my advisor heard about that and he's like, I hear you're a chemistry major. Why are you a chemistry major? And I was like, oh, I kind of had this, I liked it in high school. He's like, well, chemistry is all about the covalent bond, but physics tells you why the covalent bond works. And I was like, good point. So yeah, and I switched to physics basically right after that. Physics was such an important thing for me to learn because fundamentally, as a lot of you or your students know, it kind of teaches you how to deal with seemingly impossible problems. How do you approach something that seems really hard at first? How do you devise a strategy to solve a problem? How do you kind of test and feel out a potential solution path? No, that doesn't work. Okay, let me try another strategy to solve this problem. How do I integrate all these different things together to make a coherent understanding of a system. And that just has been so important for me developing those skills, because in a sense, politics and policy are kind of the physics of our institutions, right? They tell you how our institutions work from a granular level, and then they have these broad emergent properties that come out of them. And so that general problem solving ability from my physics background has been just endlessly useful in this field and just in lots of things, particularly, I would say a lot of people around in the world, unfortunately, but also in Congress, don't have a good grounding in basic science literacy. And so when you don't have a basic grounding in science literacy, you're more susceptible to conspiracy theories, wild theories, unmoored from reality ideas, because you don't have a good sense of what physical constraints are and what they mean. And so that is just another really important thing. So the more scientists or more scientific training that we can bring into the public policy sphere, the more important, and I think the better outcomes we'll have from politics. And so that's one of the reasons I was always really interested in politics, even though I was training in physics. And, I loved space. I wanted more space to happen. And for me, what happened was after college, I went and worked in software engineering, as a lot of physicists actually end up doing. And it was fun, but ultimately I, wasn't fully satisfied in that. And what tipped me back into the space world was I went and saw the launch of the Mars Curiosity rover back in 2011. And if you've never seen a launch up close before, that is probably one of the most powerful and inspirational experiences you can go through, because it's so visceral, right? It's very different than watching it on TV. You feel the rocket. It's so bright, you can't quite look at it. You hear it. All of your senses, plus all the people around you are reacting and excited, and the energy is amazing. And after that, I felt like, why am I not doing everything I can to make more of these types of missions happen? And so I sought out a place like the Planetary Society, which again has its scientific integrity, focused on big picture stuff, and isn't tied financially to the outcomes, and saying this is a way we can mobilize people, this is a way we can develop policy and just participate in the system. And because of my software background, I was able to kind of get a foot in the door, initially working on software and web design and development. And then I just started to do more and more and more in the policy side. And your friends who become public policy or political science majors may disagree with this. But for me, it was a lot easier to get trained to do physics and then learn civics after the fact than to inverse it, right? It's harder to casually pick up physics after learning political science, because it's just, you have to really focus on it, as you know. Yeah. And so you can learn the political science with real, key mentors and things to understand how the system works. And then you have the physics training to help me, or you, if you ever want to do this, to attack big problems, strategize how to solve things, focus and do the work. And it kind of just merged into this area of public policy. And, again, so it's kind of fusing. I love learning how things work as the physics side. I love trying to make a difference in the things that I love. That's the policy and politics side. And then space is just like one of the coolest things that we can go and explore and do. It's the last big frontier that we have to discover. And so those just meld together. And that is the long story of why I am in this position talking to you now.
Wonderful. You did a fantastic job. That was not a question I told you I was going to ask, just what made me think of, and you answered a lot of my first one there. I think you've addressed this mostly, but probably a short form answer. You were saying that you feel like people don't always have the full science knowledge, aren't scientifically literate in when they're doing policymaking sometimes. So would you say that's general, the average? A lot of it is just trying to keep people up to date, let them know what is going on, and maybe debunk part of what they think?
Yeah, there's kind of two sides of it. One is definitely keeping people up to date about, kind of the big issues, what's current in the scientific community, kind of working as an intermediary between what's really needed in scientific investment, and then making sure the people who have the power to fund and provide the resources for that are aware and make that connection. And then the other one is making sure people understand how the process of science works, and what is realistic and what is unrealistic in terms of expectations, but also people, people come up and promise a lot of things, right? And so how do you have kind of a good filter to say what is a reasonable kind of position to take or unreasonable? I think a really good example of this right now is a current kind of media infatuation with these Navy UFO videos or whatever that are going around, where you can actually do really basic trigonometry and you can answer a lot of the questions and find very banal, boring reasons, and they're not aliens, right? Mm-hmm. But because people don't have good solid grounding in that kind of skeptical, physics-based reality, kind of, again, what physics, right, teaches you to how to create, you're kind of creating increasingly improved models of the reality that we see, right? Mm-hmm. And the process of science is continually refining those models, and we're working kind of on the edges of it. But that having a good functional model of how the world works helps you say that, okay, if someone's claiming a physical object is moving faster than, light here and there, or is able to have no conservation of momentum, either everything we've learned about physics in 400 years is completely wrong, or they're misseeing something. Mm-hmm. And the first one could be true, but it seems really unlikely, right, that we've missed something that obvious. And what's more likely is maybe people are don't know how to analyze shaky videos taken in infrared and gone through image processing algorithms on for like image stabilization. And so people don't have a good filter because they don't get really solid training in physics, and you don't have a solid understanding of how the world works, then a lot of things could seemingly be true, right? That probably aren't. And so again, this is, I think, why having that kind of experience and bringing it to members of Congress and their staff. I've definitely talking to members of staff who are convinced we have UFOs and aliens coming all the time. It's always very disheartening. There's just one. There's not a ton of them. I don't want to misrepresent them. And some people, you just try to do what you can to educate them on what we understand about the universe and the world. But most people are more open to it, and they understand, they just understand the processes of how the world works. And again, connecting that and then saying, where can we make good improvement in the scientific understanding? And also to make the case that doing science, these fundamental investments in basic research, are the key to unlocking improvements to human health, into improving economic situation for people, and into improving overall experience of being alive, which is what we've seen over the last 500 years or so. And so that is just a really critical thing. And then again, just bringing that rational and skeptical thinking that you get trained to do from doing physics. And so, there's a handful, there are roles for PhD scientists as policy experts in members of Congress's offices, at various other institutions who are based in Washington, D.C., and we just frankly don't have enough of them. And so the more we can have in that sphere, the more grounded in reality I think we would be.
That's brilliant. I promised to my students I did not ask you to do a plug for why physics is great and necessary, but I do appreciate it.
I am a pro-physics guy. If it was up to me, everyone would have to take advanced physics to graduate high school if it was up to me, just to have that grounding. But I'm a bit of an extreme case in that. So I will shamelessly plug physics as much as possible.
I'll go to my next question here. I wrote a bit. I'll often have students who hear some of the costs associated with various NASA projects, $2 billion for this rover, $1 billion for this round, $100 million some for some rockets. And they're asked why we're spending money on space when we have so many problems on our own planet. I deal with this question frequently. I'm always happy to try and talk about the topic. But space policy, this is your job, your bread and butter, and you've looked way more intensely at contracts than I have. I'd love to hear how you answer this question that I'm sure you hear.
Oh, yeah, absolutely. And, fair question. And I think there are two ways to talk about this, or two ways to consider it. One is just putting things in proper context. We're not used to talking about money with various projects except for space, right? So we get, we tend to associate that it's like, then it becomes the full name of, it's like, it's not the Curiosity rover, it's the $2.5 billion Curiosity rover. So we just see that over and over again. And you never, it's not, you don't drive, but you drive on Interstate, 80. You don't drive on the $50 billion Interstate 80, right? Every time you use it. And so we're not used to comparing costs, and costs of big projects in the public sphere are just bigger than what you deal with on a personal basis, right? So it'll sound expensive because I'm used to dealing in tens or hundreds of dollars, right? But you're talking about, monies out of the scope of a $4.5 trillion budget every single year. And so the fundamental answer is we are spending and we are prioritizing funding on problems here. And you can, I've broken this down, I'll be able to break it down. The United States, just because I know it the best, and right now we live here, is for the purpose of this discussion, the United States spends something about 2/3 of all of its money every year on social programs, right? For homeless, or for housing, for Social Security, for medical issue, related stuff. The priorities are correct. And so, we can say like Social Security spends NASA's budget every 2 days. Medicare spends NASA's budget every 6 days, right? And so NASA, it's as a part of the entire, chunk of pie of government spending is less than half of 1%. And I've done the math on this. If you actually take free, maybe a physics 101 or math problem, you could say if you actually had a pie of about 12 inches and you wanted to take out a slice of that pie equivalent to NASA's budget, it would be about the width of 3 credit cards, stacked on top of each other, right? It's a very, very tiny slice. That would be NASA. And everything else is spent on everything else that we do, right? So the first answer is, in the context of what the US government spends, we don't spend a lot on space. And then we can dive in further and say, when we talk about the cost of one mission, that's not spent in a year, right? That is money that, you don't go to the Mars rover store and swipe Uncle Sam's credit card and pull a Mars rover off the shelf, right? You go and you invest, you're not paying it out, and you're also not taking that money, sticking it on top of a rocket and throwing it out into space. These projects are investment in the brightest, most capable engineers, scientists, and operational managers that we have in this country to tackle the hardest types of problems that then increase the overall capabilities, skills, and insight into, for the nation, but also of the cosmos and the natural world. So as inhabitants of the natural world, the more we understand about it, the better we are going to be. And so the investments happen over time. So it's a $2 billion project that tends to be spent out over 5 to 10 years, right? So the actual annual amounts, relatively modest. And then again, you're paying the best and brightest people, in various parts of the country. You're bringing these people up into the middle class. It's very, the types of people who come and work for NASA. It's getting a lot better. It's broad and equitable hiring practices and bringing people from all over the country to work on these really hard projects that are peaceful, that are highly collaborative, and represent kind of our best angels of our nature made manifest. And so, I like to say, like any good investment strategy, you want to have a lot of money invested in kind of your reliable, safe assets, but you always want to put a little bit into a higher risk, high reward activities. And NASA is the nation's high risk, high reward activity. Risk being you may not get everything you get out of it, but it's still, at the end of the day, you're investing in the nation as a fundamental thing for its future. So, and I can go on about this, but the big thing is that, again, fundamentally, I think we always have to push back on the premise of that question, because we are spending the priorities on people, if you just look at the amount of money, by a lot. And NASA gets a very comparatively tiny little slice. And then again, all that slice is going into the very good people investing in capabilities in the nation.
That's brilliant. Thank you. I really appreciate that. I'll often have attempt at a much more condensed, because it's the case like we're starting up class. Why are they spending this much money on this? Why does it cost that much? And I can't go into the detail that you went down, and that's wonderful. Thank you. I appreciate that. My next one is honestly one I'm looking forward to quite a bit, and I hope you're willing to play along here. I'm going to try to screen share, and I think this should work all right. And should be right here. I don't actually normally use Zoom. Our school uses Teams. So do you see this all right?
I do.
Perfect. So I've got a handful of companies here. And if you end up saying you're not familiar with one of them, that's perfectly fine. If you got them all, that's wonderful. And I have them here on a little bit of a scale that I would love to slide around with. We don't have to put somebody everywhere. We can share wherever we want. But I've got a good representation on a A through F and then the S class above A class here. And I don't know what you want to rank on. I don't know if you want to rank on the success in the future, the success so far, who you see the most promise or profit. You can pick what scale we want to use, but each of these has some interesting things happening. How do you want to go about this?
Ooh, interesting. And be delicate dance here and politically. Well, let's see. What would be, well, perhaps what is the most maybe salient issue right now? Because we're actually encompassing quite a few, I'd say maybe Virgin Galactic almost kind of sits a little bit of apart from the rest of these companies. And we can rank them in different ways. And I see maybe a couple of ways. And you could say, the most, let's see, it's an interesting one because you could say the most exciting could be a lot of them that aren't very realistic.
Okay.
You can integrate ones that are the most likely to succeed, but then the more conservative ones would be up there too. Mm-hmm. And so I guess what we could do, maybe how about this? Let's rank them in how private. We talk about private space a lot these days, right?
Okay.
Why don't we rank them in terms of which companies are the most privately held versus not what we call commercial space? Most commercial to least commercial. You want to start with that?
Sure. So I think I can, should I pull Lockheed Martin and Boeing and then ULA at the least, or sorry, they're the most?
Well, this is what we could go through, exactly. So we talk a lot about commercial space these days. And this is actually a good learning opportunity to say, there's a little bit of nuance in how we talk about this, right?
Okay.
So let's say, I would say of the group that we have, the most commercial company would be Virgin Galactic. I'd put that as A. Why is that? Because they have almost no money coming from any government contracts. They are funded by private investors, and particularly one really wealthy private investor. And right now, they're a publicly traded company on the stock market, right? You can buy stocks of Virgin Galactic. And so their goal in Virgin Galactic is to fly tourists into these kind of suborbital arcs on their space plane. And they haven't done that yet. They've been around for 15 years trying to do it. But this is a purely private endeavor. So let's go to the other end of the spectrum, ones that exist almost completely on government contracts. And again, we don't need to vilify this necessarily. Why do we have this setup? So yeah, Lockheed Martin and Northrop Grumman will be slightly higher, but not much. And why do we have this setup? And we don't necessarily have to consider this in a pejorative matter, particularly back when, not to go too much into the history of things, but after World War II, there was a fundamental realignment and understanding and reconception of what peacetime meant, right? It used to be you would fight a war, you'd rally, you'd spend a bunch of money on your army, mobilize a bunch of people and material, and then after you won or whatever, you'd demobilize and you'd lay off most of the people in the army, you'd sell off all your old tanks, and you just wouldn't do anything until the next war happened. World War I was kind of the last time any country tried to do that. When World War II happened, after the war, the US found itself in this big ideological standoff against the Soviet Union with a fundamental the concept of peacetime could never return because we had nuclear weapons that could be delivered by airplane and by missiles. And so you could never fully demobilize anymore. And so there was a fundamental shift in terms of how government saw its role to protect the nation. And so you started investing ongoing investments in national defense, which created these relationships. And through that process, they decided to not make everything in the government, but to partner with industry. So companies at the time, Martin, Marietta, these all were different companies that have now merged together, but companies that are now Lockheed Martin and now Boeing and now Northrop Grumman were all tasked with providing these weapon systems, airplanes, whatever, to the government. When NASA was formed, NASA decided to take a similar approach where it would spend most of its money contracting with private industry who specialize in serving government needs, right?
Mm.
So you can think of these companies as, they're private companies, right? But they're not necessarily competing on a commercial market. They're competing with each other for primarily government contracts, right? Which, has its, and so why do you have these types of contracts? Well, you don't want a company to go out of business if you're trying to have them make like a moon lander for the first time, right? Because no one knows how to make a moon lander, particularly in the 1960s. And so you don't want to drive a bunch of companies out of business. You want to encourage them and build up this expertise in US industry, so forth and so on. That's why you have these companies. However, we're at a point in space where that old paradigm can begin to change a little bit, because you can have more, as more expertise has been gained, you can put more risk on the private company and have more reliable return. And so companies like Lockheed Martin still mainly serve specific government needs. So they're at the kind of bottom of this list. Boeing, I'm going to put them at the D level. Why is that? Because Boeing also has, they're commercial aviation, but also they have the Starliner, and that's a commercial contract with NASA, right? So it's a different type of contract, different type of system that's more SpaceX-like. Northrop Grumman also owns Orbital Sciences, which created the commercial cargo Antares launcher for the space station. So they're kind of midway there as well. Orbital ATK actually got
They're owned by somebody
Northrop now. Yeah, so
okay.
You can even delete them. They've been absorbed into Northrop Grumman. Sierra Nevada is also kind of a mix. I put that at C. They serve, they're building a space plane to send cargo to the International Space Station. And then I'd say at B, and then let's put Rocket Lab, let's put that up at A. That's been all funded by private, for the most part, private industry. They don't have that many government contracts. They have a lot of private contracts. And then, let's put Blue Origin, SpaceX, and Astrobotic at B. And why is that? Well, they're all funded by a lot of private money, but a huge portion of their income these days is from government contracts. So SpaceX is getting a lot of NASA money. Blue Origin gets NASA money and money from the Department of Defense to launch its future rockets. And then Astrobotic has a big contract with NASA to provide lunar delivery payloads. And so they don't exist. There's not a market for them. SpaceX is a little different. You might bump them up a little higher, maybe A to B, halfway in between. But SpaceX has commercial customers that are separate than government, but also has a lot of government customers. And then a lot of these other companies kind of have a mix. And so this is kind of a way of showing that it's not as, when we talk about SpaceX, they're not a purely private company, right? Or they're private company, but not commercial in the sense that they're not just selling to commercial manufacturers. They depend and care a lot about what the government does. And SpaceX actually spends something like $2.5–3 million a year on its lobbying efforts these days. And it has ramped up over the years because it is very interested in what NASA decides to spend money on or not, and would love to have it spend money on them. So maybe this was more detail. We went into kind of a policy geek out session here.
It's great.
That's one way to think about these range of different companies. Blue Origin is currently right now suing the government to try to win back a contract, $3 billion from NASA, $6 billion actually from NASA, to fund a lunar lander. Even though Jeff Bezos is the richest person in the world and could probably dig through his couch cushions and come up with $6 billion. But they're suing the government right now to try to win that contract. And they just got their senator from the state of Washington, Maria Cantwell, to submit legislation forcing NASA to choose a second human landing system contract and add $6 billion a year to the, or overall $6 billion to the overall size of the contract to support two companies, basically hoping that the answer will be Blue Origin as that second company. So they are a mix of these commercial and government interests in a lot of these companies. So you can see here with Lockheed being the most probably government focused, and I'd say ULA bumped that into halfway because they compete. They just signed a big deal with Amazon to launch a bunch of Amazon satellites into space. Ironically, they didn't use Jeff Bezos' own space company, but they serve primarily government customers.
I wasn't sure. So do you want them halfway up or halfway between? Because
I'd put them at D to C.
Okay. because they're basically from alliance of Boeing and Lockheed Martin.
That's true, but they're a separate. So they're technically an independent company, co-owned by Boeing and Lockheed, but do have the ability to compete for contracts and commercial contracts, and they
Gotcha.
occasionally do. And they're also developing a new Vulcan rocket that will be more commercially competitive. I'd say they're primarily focused on winning government business, but again, they do contract with other companies to launch their space assets as well.
Wonderful. That was fun. I appreciate it. Thank you.
Sure.
Tiny little bonus round if you want. Do you want to look at countries?
Sure.
I threw some on here, and I think this is probably easy because countries. My students might initially say, "Why isn't NASA on here?" Because this is private space flight, at least some big ones on there. And then I thought companies that I would argue have some success, and I'm just gonna even help myself. This is Germany. This is China. This is India, and of course this one's Israel, and Canada, Japan, Roscosmos, Russia. And France is the only other less obvious one.
Yep.
You want to give you?
All right. We could rank them by budget. Which ones spend the most money?
I don't know the budget of these guys off the top of my head.
Oh, we can do it by rough ranking.
Okay,
I have the rough idea. So obviously NASA will be in the S. NASA's far and above, has the biggest budget of any civil space agency. NASA, I can tell you NASA's about $23 billion a year, which is probably more than all of these others combined.
Wow.
But it's by a little bit, but I think it's probably larger than all the other combined. But remember that 23 billion represents less than 0.5% of the entire US federal expenditures every year, right? Okay, the second one on this is probably ESA. So we'll put them in the A position. ESA's budget is kind of weirdly complicated because it is a coalition of a bunch of different space agencies, national space agencies, that they all pay into kind of a common pot to do a bunch of different types of things. They're about, give or take, $6 billion a year, $6.5 billion a year. So about a third of what NASA is, right? Let's see. After that, I would probably say China. No one knows. This is a guess. No one really knows what the budget of the Chinese Space Agency is. It's not public, and its overall bureaucracy and framework is very opaque. It's hard for people outside of Chinese government to really know exactly who's in charge and what is responsible for what. But they're probably, given what they've been doing, I'd probably put them in the $5-ish billion range. Complete guess, but I think a reasonable guess. Then I would say, yeah, you're kind of on the right track. So bring Canada down. I do know Canada's is about 300 million a year. So put that at the bottom. Canada has a very modest space agency. Mainly, they don't have their own launch capability. It's very science focused, very practical. They tend to focus on what they can contribute science-wise into other countries' missions.
Good old Canadarm.
Like the Canadarm, they had the APXS instrument on the Mars rovers. They have, they can contribute various modest scientific contributions. Canadarm's the biggest, most visible one. Then I would say probably Kennett, the French space agency. I'd say that's on the scale of a couple $2 billion a year. I put that in the C level, and I put that probably consistent with DLR and probably with JAXA. I'd say those are all kind of similar. Roscosmos, I would say less than those these days. They've had very devastating budget cuts, and they lose a lot of money to a lot of systemic corruption and mismanagement, unfortunately, in the Russian Federation right now. ISRO is probably they're a very lean agency. They're doing a lot more, but I'd say that's probably an appropriate place. And I'd probably put the UK Space Agency down at the bottom, along with Canada and the Israel Space Agency, which are both modest. You can kind of maybe even bump up India's a little bit. You can kind of say, what countries have their own launch capability, right? That's a good way. Like, if they can launch rockets, that's not an easy thing to do, right? And the more you have in terms of institutional capability, the more cost you're going to just incur, right? And so, and there's a reason why a lot of these nations have their own rockets, is because it's a national security issue. If you want to launch spy satellites, if you want to launch whatever you want, you don't necessarily want to rely on another country's friendly relationship to you. And so there's a strong motivation for nations to have their own independent capability. This is what's happened with China. That's what happened, obviously, with Russia. But Kennett also funds the Ariane primarily, which is also funded by ESA. But that's based in France. Its core competency there. And then the UK, which is also still a part of ESA, they don't have a huge system either. Canada doesn't need one. Israel doesn't have its own. But India is building its own rockets, and they have ambitions to launch people. And obviously, China has been really demonstrating some capability this year, launching its new space station and landing on Mars within months of each other. So a lot of exciting stuff happening there.
Do you feel like I left anybody big out?
These are the big ones. JAXA, by the way, yeah, I'd say a couple billion a year. They are great. They do so exciting. They have really specialized in like asteroid missions, sample return missions. They are super competent, really cool space agency. And again, they also maintain their own launch capability. They actually launched I guess you could say the UAE, they have their own space agency now that launched the HOPE mission. I'd say that's relatively modest, but it's their first big science mission. Yeah, I'd say there's a lot of space agencies out there, but a lot of them don't have that much money. And so this is where I think, again, you see quite a bit of stratification among the really big ones versus the numerous smaller ones.
Excellent. I've been telling my wife, I've been trying to keep my eye out for good JAXA merch.
Yeah.
I mean, NASA, I love NASA. I love NASA definitely. And I'm happy that NASA gear is kind of popular right now, but I was thinking like, I would definitely wear a JAXA hoodie or
I've seen critiques. Some people complain that all space logos have a swoosh in them. And I guess you have the worm logo for NASA, but the meatball logo definitely has the swoosh.
Right.
And you kind of see that here, a lot of swooshes. And
You're
I
absolutely
speak
right.
Planetary Society, we definitely have a swoosh in our title too.
Well, thank you. Let's see. Let me stop share for this. That was fun. Thank you. I really appreciate you taking time to play with me for that. I have one more official question, which you've already been addressing, and then a quick lightning round, and then I can let you go. This has been a lot of fun. You have a degree in physics. We already talked about it. You have a concentration in astronomy. Your knowledge is vast, but how you apply it is always interesting and helpful. Can you think of a situation in the last year or so where you had to apply your knowledge of physics to problem solve a situation, anything in particular?
Well, I think the one that jumps to mind that was probably the most recent was the claim that phosphine was discovered at Venus. And so the claim was that they discovered a highly volatile compound that on Earth is only made through organic processes and there's no natural pathway to making it in the conditions that we understand to exist on Venus. And because it doesn't last very long, it would have to be continuously generated in order to be detectable from Earth the way that the claim was. And so it was a really big deal of a claim because it implied that there's something biological generating this compound in a place where we kind of just assumed there wouldn't really be easy place for life to take hold. Some people had actually theorized about life could exist, kind of bacteria floating in the upper atmosphere of Venus, where maybe this was going to be it. So it was a really exciting claim, but we had to, at the organization, we had to evaluate the claim and try to provide context for our members as an educational thing about how excited should we be and what does this mean? How strong is this claim? So this is a good example of kind of what I said earlier about and this wasn't kind of from a wacko, like typing on Reddit. This was a serious scientist publishing in a serious journal. So it had a high amount of it had to already pass a lot of credibility to discuss. So we took it seriously. And so my physics background helped me in terms of how to analyze the claim, how to understand how the process of science had worked to that point, and also to kind of take that kind of critical mindset about where are the weaknesses in this argument, where are the uncertainties, and if I don't understand them, how do I find a pathway to find some deeper understanding? How am I independently able to give myself some knowledge to better analyze the information? And I find physics helped me a lot with kind of, like meta thinking, being aware of how I think and looking for kind of red flags or yellow flags in various claims that I don't have to necessarily be an expert in that field, but I could see, what are various broader ways to think about, is this a very, very bold claim and it goes against a lot of what we know. So how do we balance that out? So I think finding ways to talk about that in kind of measured steps, and what we ended up writing, and I ended up kind of writing this for our members, which was kind of just saying, here's how the process of science works, and we're going to need, verifiable, independent follow-up information, because statistically, there's always the possibility, that this is an errant observation, that someone made an error in the analysis, that, and they could all be doing it with good intentions, but until you have an independent, variable coming in to validate your other data, your uncertainty, right? So I think the physics of where you start learning about measurement uncertainty, where you start learning about standard distribution, just really basic things about measurement, where you can measure something, you could get a weird measurement purely by this kind of semi-random chance that happens in the process of the physical world and measurements and all these blah, blah, blah. That really helped us, I think, present the data in a useful way. And it has turned out subsequently, it seems that it was probably an error in their interpretation and modeling that they had applied to this data. That's still an active debate, but the follow-up data from independent observers have trended more towards our initial perspective than this kind of breathless, this is life on Venus. And, and I should always predicate this. It's like, I want to find life. I wish there was life on Venus. I want there to be life on Mars. I want there to be life under the seas in Europa. Nothing would make me more excited. And this is actually one of our big missions at the organization, is to discover life if it's out there, right? Preferably within my lifetime, because I'd like to know if that's the case. One of the most fundamental discoveries of human history. But we always have to be really careful about finding things that we want to be true. And that's when you have to be the most careful to be that kind of meta thinking about yourself. Like, if I really want this to be true, I need to be very careful about how I analyze the information, that I'm not just wishing it were true. And so I say that was a really helpful thing. And again, the fundamental thing of kind of the applied physics, right? Of understanding, I took a class in college on basically learning about how scientific instruments work and doing measurement and statistical analysis. It was a hard class. It was boring, frankly, at the time, but it has been one of the most valuable things that I have been taught, of just having to understand that, we talk about like you see in movies or in like the CSI show or, TV shows and things, where they like, oh, we'll just insert this into the measurementometer and it comes out like, and like, perfect, well, this is the answer. And there's never like, oh, this is the answer plus or minus like 30% uncertainty, right? And, or it's like, oh, that's the answer, but I like smudged the vial as it went in, so I've actually modified the input, which throws a bad result out, right? So understanding how there's kind of these chaotic systems through the complexities of just the physical world and measuring things and statistical distributions and uncertainty, not even to mention the really, the high, like real uncertainty principles about just what were the limits of our knowledge. Those are really useful things to understand. And how do you understand those types of, a really good example is the Theranos saga, where this organization was claiming to have these like magic, basically, ability to test blood. And probably if you had really understood how scientific devices are designed and work, you would be very skeptical and would not have invested your money, unlike a lot of people, which then lost a lot of money investing in something that couldn't have been true. And so understanding some of that things really helps me, and I think, characterize and interpret and mitigate you know, I'm human like everyone else. I obviously fall prey to my own fallacies, but helps mitigate that as easily. And it's been a really important and lifelong value that physics, the training in physics has given me.
That's awesome. Thank you. Appreciate that. Ready for a quick lightning round here?
Let's do it.
What's your favorite facility or location to watch a launch from?
The top of the vehicle assembly building at Cape Kennedy.
I can't get up there. That is, you win. That's awesome. Have you just done one launch up there?
I've done one launch up there, yeah. That
That's
was
awesome.
the launch of OSIRIS-REx in 2016.
Cool.
Yeah.
Is that with Bennu?
Yep.
Awesome.
Coming back this way.
What was that?
It's coming back this way now. It just left Bennu. It'll be back in, I think, 23 is when it's going to drop off its samples. But I saw it launch, and I got to be on the top of that. It's the tallest single-story building in the world, right?
Yeah, it has its own weather system up top, right?
Yeah, it's so big you can get clouds, and it's always been a hassle for them because it's so they have to keep the air moving, or else you get like little raindrops and things.
Second one, do you have a favorite dwarf planet?
Pluto.
Nice, fair enough. Follow up, do you consider what's your total count right now? I know kind of officially, but outdated, it's 5.
Of dwarf planets?
Yeah.
You know, I don't know that off the top of my head. They're finding new ones all the time, right? There's a lot of those weird gray area planets. There's like Oumuamua, I can't even do it, right? What's the one that starts with an H?
Official is
Maki.
Pluto, Maki, Haumea, Eris. Associations, whatever. But those are the only 5.
You got Ceres as the first one?
Yes.
Yeah.
Those are the 5 officially accepted by International Astronomical Union. But they haven't, there's one discovered, I forget right now, there's one discovered in 2007 that basically fits all the standards, but they kind of closed the door in 2006.
Yeah. I think that's a good example of where our desire for categorization as humans starts to break down on the margins, right? Where do you, it starts to get lots of gray areas. You get this with speciation, you get this with all sorts of weird things about when in the natural world, we're applying we're applying a model onto what we see into the natural world, which can work in very broad senses, but there's always going to be areas where there's going to be some uncertainty around it.
Very true. What future NASA project are you most excited for?
I really want to see the Europa Clipper mission. Go to Europa, and it's step 1. It's not going to land. It's not going to go through the ice sheet, but it's going to be the first dedicated mission to going to the ocean, an ocean moon with something like 4 times as much liquid water as the Earth has. And it's going to finally, it's going to confirm that there's an ocean there. And then what the really exciting thing is, if it can time it right, it can fly through a plume from the moon, a water plume that it ejects out sporadically. And it's going to have the equipment on it to analyze that water for complex organics. And so it'll give us, it won't be conclusive, but it'll be a truly exciting, and it's going to map the surface in high resolution. It's going to be just a stunning mission. This is one of the things we actually advocated for this starting in 2013, pushed really hard through 2017 to get that mission funded. It's on it, it's being built, it's metals being bent right now. It's set to launch in 2025 or 2024, I think right now. So it's a very exciting mission.
That is exciting. I like that. And then my very final one, do you have a favorite physics or favorite just general principle or law related to physics?
Well, I think I have to say the Heisenberg uncertainty principle after what I was just saying about uncertainty. And so I loved, unlike a lot of people, my favorite class in college was quantum mechanics.
Oh, wow.
I took a decent number of quantum mechanics classes, and it was definitely really hard, but it was so interesting. And what I loved about it was, again, things like the Heisenberg uncertainty principle says that there are limits to our knowledge. They're just fun, or to how we want knowledge to be. There are limits to our resolution to things, right? And I love that quantum mechanics was so counterintuitive. And there's a lot of interesting discussions that you can read in the science literature about, it's kind of amazing that our brains evolved the way that they did just so we can understand enough as much as we do, but there's no guarantee that evolution has prepared our brains to truly fundamentally get the world as it exists in ways that we don't perceive it, right? There's no reason why it has to be so. And so things like quantum mechanics remind you that the world doesn't work the way you kind of want it to, intuitively. We developed and evolved our intuitions from what we see on our macro level, these emergent output of a very weird quantum world. But the fact that quantum mechanics has been just so relentlessly correct, right, and so effective and well used, like, it's truly stunning to see, like, oh, the world as it exists around us has nothing to do and does not care whether it makes sense to us or not. But we can still develop a tool set to make that effective model of it anyway, that can help guide our use and understanding and improve ways that we can make it work for us. So again, things like the Heisenberg uncertainty principle, it's just like, sorry, you just don't get to know those two things at once.
Yeah.
And it's like, that is just a fundamental limit of reality. There's no way around that. So that's kind of a fun one in a sense. It's a good humbling reminder that the universe is not made for us, but we're kind of get to probe and explore it and understand it anyway.
I love it. That's a great answer. Thank you. Thank you so much. I appreciate your passion with this. I appreciate what you do. Without people advocating for part of this stuff, I hesitate to think what might end up happening as far as budgets and overall what we actually prioritize. So it's been a treat. I really appreciate you taking your time for this, and just a big thank you.
Oh, absolutely happy to do it. And for everyone, hopefully you will consider and continue on physics, even if you don't want to be a PhD. One more thing. I should say, I'm not a PhD physicist, right? And I am totally happy with that decision. I'm the woman I married, her undergraduate was in physics. She wanted to become, her PhD is in astronomy. And I got to watch her go through her PhD. And I was like, I am so glad I'm not doing this. It's a lot of work. Just because it was for me, I was ready to not do that anymore after I got my undergraduate degree. But you can still do so much with an undergraduate degree in physics. And so that is something maybe to just remember too, right? That you can get your master's degree undergrad, and if PhD is your thing, absolutely do the PhD. But you don't have to. And there's so much value that I got out of my training in that 4 years that you can tell, right? I'm not shy about telling how it's been useful for me.
Yeah.
In every part of how I approach the world, it's just so valuable. So, doing physics is not something you have to be a PhD physicist or professor or something at the end of it. You can do a lot of other things. You just have a really solid grounding in ways that the world works, and it's very useful.
What a great plug. Thank you.
Physics.
They're glad for that. I'm going to hit end recording right here.